Okay, so these instructions ask you to evaluate this function when n is 3. So I asked you guys to take 3 and plug it in and see what you got out. So let's just do that together real quick. 3 cubed would be 27 minus n squared is 9 times 7 is 63 plus 30 plus 13. So if I just quickly ask my calculator to do that for me, 27 minus 63 plus 30 plus 13. I get 7 also. Now, I know you're probably wondering, what in the world does this have anything to do with synthetic division? Watch this. Are you ready? Ah! Okay, so there's me plugging it in like normal. Okay, so watch this. So ignore this. I don't care about that anymore. But I know my answer is 7. Watch this. Notice anything? Yeah, so if I want to evaluate a function at a given value, I can actually do synthetic division. It's really called synthetic substitution here. And whatever the remainder is my answer. And it's so fast. So like if I jump to number 5, I don't feel like doing 4 to the 4th power minus 8 times 4 to the 3rd. I can, but that takes so long. But if you do synthetic substitution, the only difference is you're really plugging in whatever that number is. You're not doing the opposite because that's not a factor. That's an answer. That's a number. So if I just pop in a 4, whatever my remainder is will be my answer. And it's so much faster. Done. It's just an 8. It's so convenient. And you can use it for anything. So as long as you have some polynomial and you want to know the value of it at a given number, you can use synthetic substitution. So the remainder is the value of that function at that point. Isn't that something? So now, well, okay, let me let you do one without me telling you what to do. How about, well, you might as well do 3. So try 3 without me giving you an answer. It works all the same ways too. So if you had to put in a 0 placeholder, you would. Standard form, all that same stuff. So you set it up just like you're doing synthetic division. You're just going to plug in the actual number that they're giving you. And then whatever your remainder is your answer without having to go through all that other math. How cool! Did everybody get an answer? What is it? 2. 2 is my answer. So the value of this function at -4 is just 2. Cool. So, using that same idea, let's jump down to the bottom. So the bottom is a similar question, but it's asked in sort of a sneaky little way. State if the given binomial is a factor of the given polynomial. So in other words, I want to know if this will divide evenly into that. Correct. So I basically want to do my synthetic division and see if my remainder is 0. So it's sort of the same idea. So I'm going to pull down, I'm going to make sure that I'm in standard form, not missing anything. 6, 3, 2, 1, nothing. Okay, so I'll bring down the 6, 16, -4, and 6. But be careful here. What is it you think you're going to plug in? -3. If you're given a binomial, you have to take the opposite of what's there. So you're going to plug in -3. And here, I just want to see if I get a remainder of 0 or not. Hey, how about that? So, because my remainder is 0, then yes, b plus 3 is a factor of that crazy thing. Does that make sense? By the way, I mean, these are still coefficients of what's left. So in other words, if I took b plus 3 and I multiplied it by 6b squared minus 2b plus 2, so if I multiplied those two things together, I'd get right back to the original. All right, so let's try 13. See if you can figure out 13 without me talking too much. What'd you get? Is it a factor? No, you're saying. Oh, that's interesting. Make sure you plugged in a -2. I don't know what the answer is, so I don't know if you're right or not, but I will quickly find out. I agree with you. I did not get a remainder of 0, so no, this is x plus 2 is not a factor of that original polynomial. So that's all there really is to it. Pretty easy, huh? Maybe? Once you get the hang of it, then the synthetic substitution division, not so bad.